Welcome to this video lecture on some of the important topics of normalization. I am Smita Suresh Daniel, Assistant Professor from St. Thomas College, Bhilai. In this video, we will try to understand the concept of normalization in database. So, what is normalization? Normalization is actually a technique of organizing data into multiple related tables to minimize data redundancy. So now, what is data redundancy? Data redundancy is repetition of data, which increases the size of a database, and we want to reduce its size as it takes a lot of space. So let me show you with an example what is data redundancy. In this table, we have course, branch and phone numbers repeating. We can see that all the records have same values for course, branch and phone. This takes a lot of space and it is unnecessarily increases the size of the database. So what we need to do is to normalize this database so that the repetition is removed and it improves data integrity. So how to do this? This can be done using normal forms. The database normalization has many normal forms: 1NF, 2NF, 3NF and BCNF. A normal form is a process in which it has certain rules to convert it to a normal form, and through normalization we can change the raw tables into normalized tables. It is a step-by-step procedure which passes from 1N, 2N, 3N and BCNF. Each normalization has certain laws and rules which has to be done before going into the next normalization. So before going into the details of normal forms, let me tell you some of the benefits and pitfalls of normalization. The benefits of normalization are: it is easier to manage, it reduces the size of the database, it saves a lot of space and time, it has faster processing, and it removes anomalies from the data designs. But there are drawbacks too in normalization. They are: normalizing a database is a very complex and difficult task and also time consuming. A poorly normalized database may perform badly and inefficiently. Making SQL queries from user-friendly tools will become a bit difficult. All these are the drawbacks of normalization. The next topic is about anomalies in database design. Anomalies is about the design imperfection. It may contain anomalies which may be very difficult for database administrator to manage the database with anomalies. So here we learn about update anomalies, delete anomalies and insert anomalies. These anomalies will make the programmer or the administrator to organize the data such that there is no inconsistencies in the database. Let's go into the details of update anomalies with an example. An update anomaly exists when there is one or more instances of duplicated data. Here is an example. Here we see that this is a student details table having all the details, but we want to change the phone number because the phone number of the department has changed. Here, all the phone numbers have to be changed. So the administrator has to change the phone numbers of all the records. Even if some of them are not done, it will create a great problem. For this, the administrator has to change all the records, and during modification, if some records are left, then it will become a problem. This kind of problem is called updation anomaly. It creates more problems when many tables are in relation with each other and they are not updated in the related table. Then there is data inconsistency. So, in order to normalize, we have to remove all the anomalies and bring the database to a consistent state. Another important topic is functional dependency. A functional dependency is a relationship between two attributes in a table, that is, the primary key and the non-key attribute within a table. Here we see a relation R having an attribute Y, which is functionally dependent on the primary key. We can write this as Y is functionally dependent on X, means there is a relationship between Y and X. For functional dependence, every non-key attribute must be fully dependent on the primary key. Here's an example for a relation table student. We have all these attributes and we know that each student has a student ID, and that ID is related to his name, his date of birth, which is unique for the student ID. But a student can have more than one phone numbers. Thus, we know that phone number is not functionally dependent on student ID. So, this function, student ID and phone number, does not hold for the table because this is not desirable, as the non-key attribute student ID is not fully dependent on the primary key. So let's go to our next topic, that is joint dependency. A table is in joint dependency if it is created by joining multiple number of tables, and each table has a subset of attribute of the main table. Like, for example, if we have joins R1 and R2, and C is a common attribute for R1 and R2, will give us a joint dependency relation R. Then we can say that a joint dependency exists in R. Here R1 has three attributes A, B, C. R2 has two attributes C and D. We see that there is a common attribute C in R1 and R2. So when we create the relation R, A, B, C, D, it will be joint dependent, as all the data of R1 and R2 will be existing in the relation R. This is known as a lossless decomposition, where none of the data is lost from R1 and R2. I'll show this with an example. In this example, we see that there are three small tables: employee skill table and employee job table have EMP name as common. An employee job table and job skill table has EMP job as common. So we see that there is a joint dependency between these two tables and these two tables. So the join of all these three tables will give rise to employee table. We can arrange this as employee name, EMP skill and EMP job. And we see that each small tables are a subset of the bigger table. So we can get a joint dependency in this table, and hence this can be called as normalized table. Thank you.